Now we're moving on to the two-sample t-test. So first we're going to talk about what we already know with the one-sample t-test and how we build on that to do the two-sample t-test. Then we're going to talk about when in general to use the two-sample t-test and the assumptions of the t-test. And then in the next video, we'll do confidence intervals and hypothesis testing for the two-sample t-test. So first, building on what we already know with the one-sample t-test. With the one-sample t-test, we have one group, one sample, say German Shepherds, and we're measuring a quantitative variable on them, maybe weight. So the confidence interval would give us an estimate of the true mean weight of all German Shepherds. So we're not talking about individual German Shepherds, we're talking about the mean weight of all German Shepherds, So it gives us a number, maybe the estimate of the true mean weight of all German Shepherds we think would be somewhere between 70 and 80 pounds. So it gives us a range in which we expect to find the true mean weight of all German Shepherds. When we move to two groups, maybe we're talking about German Shepherds and Golden Retrievers. Now the confidence interval estimates the difference in mean weight between the two groups. So maybe German Shepherds weigh less than Golden Retrievers on average by somewhere between 10 and 20 pounds. So this would give us an estimate of the difference in weight between German Shepherds and Golden Retrievers. Hypothesis testing, when we have one sample, we make a claim that our mean is equal to some number. So like the mean weight of German Shepherds is 70 pounds. So this would be a number, like the mean weight of German Shepherds is 70 pounds. When we have two samples, German Shepherds and Golden Retrievers, then our null hypothesis is that there's no difference on average. So on average, German Shepherds weigh exactly the same as Golden Retrievers. And then our alternate can be less than, if we think German Shepherds weigh less, or less than 70 pounds, not equal to if we think it's different from, greater than if we think it's greater than. So we're still working with means, but now we are working with two groups instead of one. So our confidence interval is to estimate the difference, and our null hypothesis is that the means of the two groups are the same. So to do a two-sample t-test, we need two groups compared on a mean. So let's look at the examples on your sheet. So we wonder, for example, how much taller on average are tulips than daffodils? Well, we have two groups, tulips and daffodils, and we're comparing them on height. Height is a quantitative variable. We summarize that with a mean. So how much taller on average are tulips and daffodils? This is exactly the situation in which we use a two-sample t-test. In this case, we're wondering how much taller? How much taller? So we would want a confidence interval to estimate the difference in average height between tulips and daffodils. Next one is the percent of forsythia bushes in bloom the same as the percent of redbud trees that are in bloom? Well, we have two groups, forsythias and redbuds, but now we're comparing them on a percent, the percent in bloom. So we would not want a two-sample t-test. We'd use the two-sample z-test that we talked about earlier. This is a yes-no question. Is the percent of forsythia bushes in bloom the same as the percent of redbud trees that are in bloom? So we do hypothesis testing, a two-sample z-test for proportions. Next one, how much on average does a tulip grow in 1 week? Well, we have two samples, the tulips before and after, but they're the same tulips. So these are paired samples, the same tulips measured twice. So we would want the paired t-test, which we'll be talking about in the next chapter. Since we wonder how much is it growing in a week on average, well, we do a confidence interval. So a paired t-test using a confidence interval to estimate the average change in height for tulips. Do baby eagles and baby hawks cry on average at the same volume? Well, we have two groups, eagles and hawks. No mention of matching or pairing of any kind. We just have a bunch of eagles and a bunch of hawks, and we wonder if they are the same volume on average. So two groups compared on a mean, average volume in cries, and we're asking a yes-no question. So our null hypothesis, we do hypothesis testing, and our null hypothesis is the mean cry volume of baby hawks is the same as the mean cry of baby eagles. All baby hawks and all baby eagles. And then finally, do bunnies, squirrels, and skunks have the same average number of babies? Well, now we have three groups, bunnies, squirrels, and skunks. We are comparing them on a mean, but we have three groups, so we would not use the two-sample t-test. We'll be using the analysis of variance, which we'll be talking about later in the semester. So we need two groups compared on a quantitative variable. If we're trying to estimate the size of the difference, we'll use a confidence interval. If we're seeing is there a difference on average, then we'll use hypothesis testing. The assumptions of the t-test, well, we have two distinct populations, two completely separate groups with no matching or pairing, so the samples are independent of each other. So look at the study design and see if that's true. We assume that we either have a simple random sample from each population, we've chosen people at random, or if we're doing an experiment, we've assigned people to the groups at random, but we need to have that randomization. We assume that both populations have a normal distribution for that quantitative variable. So whether it's the weight of dogs, or whether it's the height of tulips and daffodils, or whether it's the volume of cry for eagles and hawks, but whatever quantitative variable we're looking at, we're assuming it has a normal distribution with no outliers. Which of any of those assumptions may we break? Well, the only one we may break is that normal distribution one, and that's if our sample size is at least 40. Then the distribution may be skewed, but we may use it anyway with a sample size of at least 40. So there are actually two sample t-statistics. One assumes equal variances and one does not, and we will only be learning about the one that does not. That makes fewer assumptions, is just safer, and so that's the one we're going to learn. So in the next video, we'll talk about hypothesis testing and confidence intervals when we have this two-sample t-test, two groups compared on a mean.